Welcome to Professor Mike's video about Chapter 6. Chapter 6 is all about confidence intervals. Okay, so what we're looking for initially, at least in the first two sections, is a confidence interval for the mean. All right, what they mean is for the mean of the population. The basic idea is this. You don't know the mean of the population, so you take a sample, you get the mean of the sample. Now if you think of a number line, you put the mean of the sample right there. They call this the point estimate also, by the way. And then what you do is you make an interval around that, okay? And this interval has this margin of error. Right? So from the mean plus the margin of error is the high end of the interval. And from the mean minus the margin of error is the low end of the interval. And as a confidence interval, so you do something like you make this interval in such a way that you're 90% confident that the actual mean of the population is in there. Okay? The way you do that all comes down to how you find E, this margin of error. Okay? Now you want to try to keep this basic construct, or whatever you want to call it, in mind. This is all that's happening. You find your best single estimate. For the mean, it's the mean of a sample. And you find your margin of error, then you go the mean minus the margin of error to the low end, mean plus the margin of error to the high end. Now, in 6.1, we're doing confidence intervals for the mean with a large sample, n bigger than or equal to 30. Okay? Now, in this case, we're able to use the normal distribution, all right? So our E is ZC times the standard deviation of the mean of the sample. In other words, E equals number of standard deviations, and what that is, it's the number of standard deviations that match up with the confidence level you want, times the standard deviation itself, right? So if the standard deviation, for example, was 3, and you needed 2 standard deviations, E would be 6. Now, when you get to 6.2, in this case, the standard deviation of the population is unknown. The sample size is less than 30. In that case, as you'll learn, the normal distribution doesn't work. Okay, so we have to use something called the t-distribution. But this turns out to be, this uses the t-distribution to get a count for the number of standard deviations. So again, the margin of error is the number of standard deviations, right? The number of standard deviations that you need to match up with whatever level of confidence you want, times the standard deviation. All right. So let's look at the last one. In 6.3, instead of looking for the mean like we were before, what we're looking for is something called the proportion. And when you do 6.3, you'll see what that is. But you'll notice, so the confidence interval then is, what you use is the proportion of the sample, which is what they call p hat, right? So then your confidence interval, remember what we're looking for is the population proportion. So you take the proportion of the sample, and then you build a confidence interval exactly the same way as before. The formula works out a little different, right? But it's the point estimate, the midpoint, minus the margin of error, up to that midpoint plus the margin of error. This time the midpoint is the proportion of the sample. Now, you'll notice in this case we're back to ZC, and then what happens is these proportions have a different kind of distribution. This right here is the formula for the standard deviation. So again, the margin of error is the number of SDs, number of standard deviations, times the standard deviation. All right, so you see that every time the margin of error is the number of standard deviations that match up with whatever confidence level you want, times the standard deviation. So what you end up doing is using the finding a value thing back from like in 5.3 to get in 6.1 and 6.3 a z-score, and in 6.2 a t-score, and then you multiply that times whatever the standard deviation is in that situation you're in. All right, so let's go just through a few things. So in the formula here, ZC is the number of standard deviations away from the mean that matches up with the desired confidence level. In 6.2 it would be TC. All right. In 6.2 you'll learn more about this T distribution. For the T distribution, we don't need to know the mean or the SD. All right. Get that again, for the T distribution, we do not need to know the mean or the standard deviation, but we do need to know something called the degrees of freedom, generally abbreviated DF. It's simply the sample size minus 1, all right? Degrees of freedom equals sample size minus 1 and minus 1. Now, when you're going to use the T distribution, when we're finding probabilities, it's TCDF, okay? It's the same thing as before. It's the same thing before in the sense that you start by hitting second and then DISTR, just like you did when we were going to do stuff with the normal distribution. But if you look on that screen, just below the commands for the normal distribution are the commands for the T distribution. Okay. Now, which commands you see exactly, though, depend on which calculator you have. So, the ones you care about are TCDF, and if you've got it, INVT, or maybe it's, yeah, I think it's INVT. It might be T inverse. In any case, TCDF works just like the normal CDF did, except we don't, like I said here, we don't need to know the mean or the standard deviation. So when you have the TCDF, you put in the lower limit, right? Or if there is no lower limit, you use the minus 5 nines. You put in the upper limit, or if there is no upper limit, you put in the 5 nines. And then the degrees of freedom, and close parenthesis, and hit enter, and you will get your probability. If you're going to use the inverse T, you put in the probability you want, like say 0.05 or something. Well, you put in the probability, and then you put in the degrees of freedom, and out comes the inverse T. However, the problem with the inverse T is this here. Is not available on TI-83s and older TI-84s. All right. The table for the T distribution that they give you is pretty quick. There's not nearly as many numbers on it, so it's not really a burden to use the T distribution table. Okay, I use the T distribution table. I have an old TI-83. I used to have one of the newer 84s, but I lost it, so I've just gone back to using I haven't bothered to replace it. I just use my TI-83 and the T distribution table. Now, another thing I want to say is this. There are 1 or 2 questions in the homework where you will need to find TC, that is, find a value, for a probability that is not in the table. Now, this will not happen on a test, all right? On a test, I'll be sure that the values will be in the table. But I wanted you to kind of get a taste of this. If your calculator has the INVT command, this won't be a problem because you'll just stick it into the INVT. It doesn't care what the probability is. However, if your calculator does not have this command, then you can still do Excel. So here's the command. You open Excel and you do this. You type an equal sign in any open square, T.INV, open parenthesis, put in the probability, and then the degrees of freedom. So, T.INV, well, you need the equal sign, the probability, comma, and then the degrees of freedom. So let's see how this works. Okay. So let's say we're going to do 0.05. So I'm going to type an equal sign. The equal sign tells Excel you're going to do a command. So just as I did, just like I wrote, T dot INV, open parenthesis, put in the probability. We talked about 0.05, so we'll do 0.05, comma, and let's say the degrees of freedom is 12. All right. So T dot INV, 0.05, comma 12, close parenthesis, and then hit enter. And there is your T value. That's the TC for that, if you will, minus 1.78, whatever. If you put the cursor back on it, here you see the value. If you look up here, you see what I typed. Okay? That's all there is to that. Okay. That'll happen on 1 or maybe 2 homework problems. Really, the only difference between the calculator and doing this in Excel is that in Excel you need to start with the equal sign. Also, really, you'll notice after I hit the last parenthesis, the closing parenthesis, I did hit enter. All right, so there's one more thing I want to talk about here. And this is really the only kind of question that I get a lot of questions about. People get stuck on different other stuff. So if you get stuck, by all means, feel free to give me a call. It's easy to get stuck on something almost anywhere. But for the most part, you're going to be asked two kinds of questions in this section. The first type asks you for a confidence interval. Okay? You'll learn how to do these. The second type asks you to find the sample size needed to get a desired result. All right? There is a small trick to this. There's a formula for finding n. Exactly what goes into the formula changes depending on what distribution you're using, but the formula itself is not the trick. The trick is that you must round up to the nearest whole number. Now they say this in the directions, but people sometimes don't know what round up means. The sample size is always a whole number, right? You're going to take a sample with a certain number of items in it. Let's say you do the calculation and you get this is your value. N equals 43.121. Okay? So what does round up mean? Well, round up means do not follow the normal rounding rules. Up means go to the next higher whole number, no matter how small the decimal part. If n equals 43.121, the final answer is 44, right? Even though it was 0.1, we went up to the next whole number. That is what round up means. The only other basic piece of advice I would have for you is when you're in 6.3 and you're working on things with p and p hat, okay, be very careful about your rounding. I would always, when you're doing your calculation, give it 3 or 4 extra decimal places at a minimum. What I mean by that is, look at the question. Before you start, you'll notice at the bottom it'll say something like it wants the answer to a certain number of decimal places. Let's say it wants it to 2 decimal places. Well, then when you're doing your calculation, actually, I would use 6 decimal places in every step until you get to the very end when you're all the way done, and then round it down to 2. Okay? 6 a lot of times is overkill, but I would say better safe than sorry. All right, that is it for this one. I hope you found this helpful.